All right. Paul, we can see your screen. Thanks for leading the charge today. I'm going to give this a second because I can see that people are streaming in. The way that Zoom normally works with webinars is, from what I'm experiencing and finding out, is that like with GoToMeeting, everybody is in like instantly. With Zoom, they kind of trickle in, like one or two or a few at a time over I don't know, 30 seconds maybe. So that's why if you can hear my voice, I'm kind of delaying and doing a talk up because we're waiting for more people to come in. So I can see that we've appeared to have leveled off, which is good. So good afternoon and welcome everybody to our webinar today. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI. And we're very excited today to be able to present this webinar in our Creo series regarding model-based definition. So with us today, who's going to lead the charge is Paul Dye. He's an application engineer with PTC. He has helped us out with the majority of our Creo demos and webinars. He's very knowledgeable. And I had a thought and I just lost it. So he's going to give us an overview of model-based definition, what it is, the problems that it can solve, and so you can figure out if it's something that's useful for you. If it is, then we can talk more about that. But without further ado, he's also going to do a quick demo. So if you have any questions, just type those into the chat box or the question area. I'll try to answer them as we go. But if not, we'll definitely answer questions at the end. And Paul, what are we looking at? About 20 minutes?
Yeah, we'll be done in less than a half hour for sure.
Okay, good deal. Yeah, we like to keep these kind of short. So Paul, take it away. Thank you.
Yeah, thank you so much, Rob. And thank you for having me on today. Again, my name is Paul Dye. I'm an application engineer here with PTC. And I am going to go through and talk a little bit about one of our strongest capabilities with Creo, that being model-based definition, and also how that factors in with geometric dimensioning and tolerancing. So again, if you haven't seen this or haven't worked with this before, something that we've actually had in Creo for a little while now, but in more recent releases of Creo, we've looked to add a lot of different capabilities into it. I'm going to go through a lot of that today, allow you to see what some of these different tools look like in the context of Creo. So again, like Rob mentioned, if you have any questions, feel free to drop that in the Q&A, and we can definitely touch on that towards the end. So without further ado, we can go ahead and get started here. So one of the things I like to make sure I do before we go through and talk to the capabilities is address some of the challenges we typically see from people working out in the industry today. So looking at it from a 2D print standpoint, these are in general just very costly, a lot of times incomplete. Whenever it comes to transferring design information, it can be really hard work, right? It's difficult to get all the information in there, and it can really lead to being a mess. And that's what you can see on the screen here. It's very challenging to read all of that, let alone get any useful information out of these. So reading drawings is almost a skill that seems to be dying off nowadays, but it's still one of the only ways that we have of transferring our designs into the real world and getting them manufactured. So that can be a problem. And we thought that 3D modeling could be a solution to this type of problems, but those models also sometimes have problems as well. It can still be quite a challenge to include all that information around dimensioning and tolerancing, build that into the part. And that's because our drawing information contains a lot of small details, and we can't just have a model with all that information hanging around. Also, around all the work we have to do, there's standards that we have to be able to adapt to. That's because those standards, whether they're ASME or ISO, they're always evolving, and we have to be able to keep up. And looking at it from a GD&T standpoint, that in and of itself can be a very robust, very effective way of communicating design intent from parts and assemblies, but it can get complex. A lot of symbols, a lot of markers to use, and with those ever-changing standards, it can be a lot for you and your team to keep up with. But for GD&T to really be useful at the end of the day, it has to be complete, and most importantly, has to be correct. Because if your models aren't fully defined by those dimensions, tolerances, it kind of defeats the purpose. So in order to combat a lot of those challenges, what we've done is work with Creo, and especially over the past couple releases, to give you tools to work with GD&T and get your entire enterprise up to true model-based definition. A lot of things that we saw, especially starting around Creo 4, we started seeing a lot of enhancements being added into MBD and model-based definition around, first of all, the datum feature symbol. So all the symbols that you would need are all going to be under these different standards, right? So we have them all being able to work within those standards. We have them all available. And now if you have any mistakes in laying out those dimensions, the system's actually watching out for that. It's going to let you know exactly where that's wrong, and you can go through and start to fix those up. We also made enhancements around datum targets, so how we define those targets, define the call outs, and also define whether a datum is within a target or not. So it could be personal preference or sometimes even a standard that you have to work around. And a lot of things that we've improved have been around creating GTOLs. So overall, making it faster, making it easier, and when it gets more complex, more accurate. So if you're getting an error or missing a component, let the system tell me. So because the system has all those different standards built into it, it knows whether I need to add something in or maybe remove something. And looking at annotations, we have enhancements around recognizing the surfaces that are referenced in an annotation. So say you happen to change a particular surface or a feature, the system will throw out a warning so you can go through and make sure that's being edited correctly. And also for combination states where you can view the models or assemblies in different views and orientations, we're able to view those models with different appearances as well. So you could see here, maybe a particular feature wouldn't make sense just looking at it from one state, but if you're able to make that more transparent around the outside, you can see, okay, that's referencing the internal bore there. So allowing us to make a lot better use out of those type of combination states. All right, we also have new fonts for both text and symbols. So like we saw earlier with all those new symbols, we can customize them if we'd like to. We also have the ability to favorite certain things and allow you to see a history of symbols that you've been using. So you can really make sure you're getting to what you need a lot faster. And again, as those standards keep evolving, Creo is going to keep evolving right alongside them. So for both ASME and ISO, as they're released, Creo is going to work to include those in these extensions as well. And working with model-based definition and sharing out these type of 3D annotations, one of the questions you might have is, how are our frontline workers going to actually consume this information? Well, there's many different options. We're now able to share off into a type of step file, which is essentially allowing you to include all that information around dimensions, tolerances, and build that out into the model itself. And we also have with Creo a free viewer called Creo View for being able to take those in, view all the different states, and share those off with whoever I need to. So people on the shop floor can use that. Anyone in the enterprise can use that for free. All right, and looking at it around GD&T, we also have an extension that we've built into Creo called the GD&T Advisor for working with this type of model-based definition workflows. It's an extremely useful tool, and it's helping to provide guidance on the application of GD&T, as well as validation that has been done correctly. So we'll see this, again, it's a guide for users. So if you go to apply a certain tolerance, it'll give you suggestions based on the part of the feature that you selected. It also won't give you options to apply a certain tolerance if it would be invalid for that feature. And the advisor informs you whether your features are fully constrained, unconstrained, somewhere in the middle. And really what it's doing is it's helping to educate users, right? So if you get a message in our advisor tree, you can ask for more help, give more context into the advice that we're receiving. So we're better able to understand the changes that need to be made. And like I mentioned earlier, it's keeping up with all the latest standards that you're going to work with. So making sure that it's keeping those in mind and you don't have to try to think about that while you're working with it. And one of the biggest things with any of this is that it's seamlessly integrated with Creo Parametric. You just simply take the model that you're working with, click on the GD&T Advisor button, and you get to work. And you work in a very simple, streamlined model tree. You have each feature along with all the associated tolerances. You can click and edit any of those as you go. So just like your standard model tree that you might be used to working with. And even if you have existing annotations before you would enter into the GD&T Advisor, we also have tools for being able to utilize those as well. So no need to throw away or get rid of any annotations that you already have built out. And before we hop into the demo, I just want to take a quick moment to touch on some of the enhancements that we see in the world of model-based definition, or MBD, in the context of Creo 8, so our latest release of Creo. And that starts here with symbols, right? So we introduced new streamlined workflows for placing and editing symbols. We give you a very rich gallery of standard symbols to work with. And now users have quick access to commonly used symbols. So it's allowing you to easily customize that, categorize symbols that exist in that gallery, making it easy to work with. And symbols also now support their semantic definition in the same way that it works for any annotations or notes. That means that now you can do a semantic query on a symbol, lets you know which references are actually associated with a particular symbol. And this also works well with the weld symbol as well. So there's a special type of symbol that are also now semantically aware. And looking at it for the GD&T advisor in Creo 8, this is something that we actually expanded to support assemblies now. This has probably been one of the most asked for enhancements around model-based definition in the GD&T advisor specifically. So it helps users to fully constrain their models in the context of that assembly. Also streamlining the process of adding new annotations to the model that don't currently exist. You can just switch between the annotation tab, create those, get right back into the GD&T advisor. So you don't even have to leave it if you don't want to. And also a new interface for managing annotation mismatches. So particularly say you're bringing in a model that has legacy annotations, the mismatch interface will now identify any issues that come up during the conversion, as well as give you tools for going in and addressing any of those issues. So a lot of great capabilities that we're really seeing with every single release of Creo going forward. And with this, we can go ahead now and jump into a demonstration to actually see what this would look like in the context of Creo. So first, what I'm going to do here is just go through a quick workflow of what it actually looks like just to do model-based definition work in the context of Creo. This is all just out of the box. Any package of Creo has this available to you. And then after this, we're going to go through our extension with the GD&T advisor and show how it really makes this process much more streamlined, much more efficient, and at the end of the day, much more correct. So for our demonstration here, we're going to be working with a gripper link from one of our designs. And to do this, we'll start off in our annotate mode. This is a mode that's used to keep different sets of annotations grouped together in a very clean, easy to use environment. So first things first, we'll use our geometric tolerance button. So say we want to apply a GTOL to our top surface here. It's just as easy as clicking on the area that you want to apply it, drag it out. And after that, you can go ahead and set the geometric characteristic. So in this case, we're going to do a flatness. And it's done. So quite often after that, we'll go ahead and add on a datum tag. And it's the same process of defining the surface that we want to put it on, and we're good to go. And once we have that reference defined, we can also change how that tag looks too. So we can change where it's located. We can add an elbow or don't have one. So the whole process, as you can see, it's very fast, very easy. You just keep moving on to other parts of the model from there. So we can go ahead now and look at one of our other annotation sets down here at the bottom as well, once we had things updated. And maybe now we want to work with a dimension around this center bore here. So starting with that, we can go ahead and drag out a certain dimension we have there. And we can go ahead and start by adding in a tolerance to that value as well. Maybe we want to see a plus minus for that range. We're then able to take those values, set them to whatever we need to from there. And now from there, we can also add in a geometric tolerance right on top of that dimension. So in this case here, what we need is a perpendicularity. So easy to go through and select that. And then you simply go through, put in whatever values you need, define which datum that you want to reference, and that's going to update for us. And like I mentioned earlier, very often in the process, you need symbols, right? So you can see with this, we can add in, say, a diameter symbol from the new full library of symbols there. Maybe we also need to add in a max material condition, and again, the GTOL block updates automatically for us. And you can see there, if I put in something that doesn't make sense, then the system throws us an error, says, hey, that's an invalid symbol you added in. So making sure that our values are correct and we're doing the right things. And just as we did before, we need a datum tag. So for this one, let's go ahead and pin it on the width line. And also add in the surfaces that we want to reference for that datum, and we're good to go. All right, so now that we've finished up our definition of the center board, we can move on to define these mounted holes down here. So start by getting our dimension here, pull that away from the model so we can clearly see that. And as we did with the other hole, we can lay out a range for that. You can define exactly how many decimal places should be displayed there. And we can also make additions to those tolerances. So for example, since we have 4 of those holes, we can show that in our call out. So as you can see, the process is pain-free to use. You can add in the GTOL. In this case, it's going to be a position call out that we want with that. All right. And go through, set the values, check any of the references. So for this one, it will have a secondary reference as well. So we'll go ahead and add that in reference to datum B as well. And in addition to all these different capabilities, we can also add in additional text to any of the sides of our callout for additional information. So now whoever sees this callout knows that it's referencing all 4 of those internal surfaces where the holes are. We can go ahead and add that in. And like we did earlier, also click and define the surfaces as references. So again, these callouts aren't just numbers, not just letters. There's actually true intelligence built into that to make sure that we're making updates when we need to. All right, let's go on to our last one here and just do a couple more edits like we might need to here. And like I mentioned before, the process works perfectly with the annotations that we already have laid out. So for this surface here, maybe I need to set the perpendicularity with reference to datum A. So we can go ahead and define that. We can also open up our additional text if we need to remove some of the stuff that we had from our other surfaces if we need to. Go ahead and get rid of that. And the callout just simply keeps the info from the last one, makes it very quick to repeat some of those callouts like we very often need to. And now we can go through and see some of the options around building out the dimensions here on the model. So again, with any of those, quick to select those, quick to define the decimal places, along with exactly on the surfaces that we want to reference. So for example, here, maybe we want to show the max dimension from one side to the next. Well, do that very easily. And similar to like what we did with the prefix on one of the earlier ones, we could also set a suffix here if we need to, telling that it's going to be a reference in this case. All right, so once we have all that laid out, we can go ahead and update our annotations, and then we can save off our model and do that however we need to. So we can save the model into a number of different file formats. Like I mentioned in the presentation, we have new options around that step file, specifically the AP242, for including all the different annotations we built out. And now that we have the file saved off, it's ready to be used downstream for whatever purpose is necessary. In the shop, in the third party working with this, it's however we need to use it. And from here, now what I want to go through is a little bit about how we would work with the new GD&T advisor extension. So again, everything that we did there before this was all just out of the box Creo. And now what I want to do is utilize some of the capabilities that we have now within our GD&T advisor extension for making this process, really taking it to the next step here. It's very easy to get to. It's just right up on our applications tab. Again, this is providing us expert guidance on the application of our GD&T, as well as validation that we've done this correctly. So to show how this works, first thing I'll do is start with the first service on the top here and pick what we want to do. Right. And once we've selected that, when we go into the callout here, we can actually see that a lot of the things that were available before are now grayed out, right? And it's because it's built into this tool. It knows exactly which things would not make sense for our scenario and what things actually would, in our case, be the best things to use. So you see anything that's highlighted in green is going to be recommended for us to utilize, and anything that has an asterisk is the most recommended for that feature. All right, and now the system builds out the datum feature, and we're good to keep moving. And I can do the same type of things I was doing before, right? So such as building out the upper tolerance ranges for that hole if we need to. In this case, perpendicularity is the one that might make sense for us here. So we can go ahead and lay out our range. Go ahead and select the characteristic. We can see that, yes, in fact, perpendicularity was that. And we have a few more things that actually are available to us, which is fine. We're still allowed to use them. But in our case, we can just let GD&T advisor let us know which particular characteristic is going to give us the most bang for our buck and really be the best type of characteristic for our particular feature. All right, and with that, again, we can just go through, set the value to whatever we need to, set the material condition, build out another datum feature. And now that's going to be our datum B. And once those annotations are built out, they just work like standard annotations. You can go through and do everything you would otherwise, but the GD&T advisor makes it so much faster to do that. So just because we started out in the GD&T advisor, you can still go back in and add whatever notes you might need to. It really works in both ways. Working on our next feature here on the side, we want to define the diameter for that hole. Let's again go ahead and define the range for that. And when we look back into the conditions, we can see that the advisor recommends the position characteristic. So we can still use any of the tolerances as long as they're valid, but otherwise we just use the one that the system recommends. And we could add in multiple different tolerances if I'd like to. So I could also add in a parallelism for that feature in reference to datum A. And once we're done, we just click to run the GTOL. We can see that it actually gives us a composite GTOL. So not only fast and easy there, but most importantly, accurate. And that's really what you want. You want to make sure that everything you're doing is going to be correct. And building out another one here on the left-hand side, we can start to define the hole down there at the bottom. So for that one, we're just going to need a positional tolerance here. Okay, we can give it a value, give it a reference, again, a specified range. And because we don't need a new datum there, we just accept it as is, and we can just drag that box out so it's able to be clearly seen. And now zooming in on just one of these holes here, we can obviously see that it's a pattern, but our system here in Creo can also recognize that it's a pattern. So we can go through here and apply whatever tolerance is necessary. And then here, again, we might have a positional tolerance. But once we do that, we can actually have it applied to all 8 of these. So once we've laid out the symbols, the values, we accept it, it actually runs and applies to all 8 of those surfaces. And next, we can just go ahead and put that call out into a position that our user can easily read, give those downstream users a bit more information. If we'd like to, we can just state that that's being used in 2 places. Just do that right from the additional text. All right. And after we finish that call out, we can also check over in our advisor tree on the left here. We can actually see that it's giving us an error. So our call out has a 0 tolerance that isn't allowed. Well, sure enough, we must have forgot to put a tolerance in there. So we can just open that back up and the options that we have for that, define a range for that value, define any of the values that we need there. And once we accept those changes, we can check the advisor tree. And now we have a valid dimension. The error message goes away, and the system is always checking for those things and make sure that we're doing the right things. And one thing that I want to show here is I can utilize the show hide constraint state. So we can see here exactly which things are fully constrained, which are highlighted in green, and in gray, any of the surfaces that are unconstrained. It really helps me to further understand exactly where I'm at with the model. If we had things that were partially constrained, it would be yellow. And one of the things we could also do here is in our properties, we can have the model controlled by an overall note. So I can say the general profile needs to be a particular thing, right? So we can just go ahead and do that in our properties. So let's give it a general profile of 0.002. And once we go ahead and select that, we can notice that this note up in the top left corner gets added in. Right, so it's making sure that everything that was going to be gray is now actually constrained by a surface profile in the node. And of course, once we're done in GD&T Advisor, we can simply just exit out of there and we keep all of the callouts and the annotations that were created and we can get right back into model. And so move things around, make those features look exactly how we want them. So like here, we can see one of our annotations is upside down. So we just very easily change the orientation there. Very fast, very easy to get those things looking how you want them. So just keep making changes and it's on to the next one. And once we're finished, we just have a really great geometrically tolerant part. So you could save that off, send it off for manufacturing and keep moving on with the design. A lot less problems that you're going to have once it's time to get these things manufactured or fabricated. All right, so that's everything I wanted to cover from a demonstration standpoint. And before I pass it over to Rob to take any questions or to wrap up for the day, I just want to very quickly wrap up with really some of the value that we're getting for with this, for moving forward with model-based definition in GD&T. So one of the things that we see out in the industry for people that are starting to do this is first and foremost reducing scrap and failure, typically caused by poor communication, because if we were to underdefine something, that leads to more guesswork, a lot of times failed products. So that's one of the things that we're really starting to see now with model-based definition is an improvement there. And also an improvement to productivity, because it's much easier to build these out from scratch, make edits, share them off. And in general, it's working in an environment that's much more rich, much more complete throughout the enterprise. And looking at it for the GD&T advisor, we now have more educated designers. There's always going to be better if you have more information. So that's what we're doing by using the GD&T advisor. We now know exactly what each feature is doing. And if you don't, you have a very quick and easy way to figure it out. and just overall improving the quality of designs. They're validating our tolerances at every step of the process. So if something's wrong, system immediately lets us know, and that's well before we would ever hit the save button on any of these. All right, so that covers everything that I wanted to touch on for both model-based definition and the GD&T advisor. Again, hugely beneficial tools. A lot of different companies are starting to move over into this way. It's definitely a way that we start to see manufacturing and fabrication done in the future. So again, if you have any questions, I will be happy to answer any of those or get answers to them going forward. And with that, I can pass it over to you, Rob.
Sounds good, Paul. Thanks, brother. Appreciate it. I'm going to share my screen for a minute. If any of our panelists have anything to add, you can unmute and contribute. So stop. Yes. There we go. So I want to thank everybody for attending today. If you need to contact us for any reason, if you want to see a more detailed demo of the GD&T advisor, if you want to talk a little bit more about this, this extension, we're more than happy to do that. You can respond to the email that I sent. Any responses to those emails for the webinar invites come directly to me, or you can contact us at info@3hti.com. So I think that's going to wrap it up for this webinar session. I will have the recording up on YouTube probably sometime today, and I will send an email out to everybody who attended so that you have access to that webinar recording. So Paul, thank you very much for leading us today, and I'd like to thank everyone who attended. And have a great day, and we look forward to seeing you for next week's webinar. And you'll see that invitation tomorrow. Thanks, everyone. Take care.